Find any slant, oblique asymptotes of the graph of f of x equals x squared plus 2x plus 5 in the numerator and x plus 1 in the denominator. So as far as the cases of oblique or slant or horizontal asymptotes, you look at the leading term in the numerator, and if the leading term has a higher degree in the numerator than the denominator, we get this slant or oblique asymptote. If they are equal degrees, you get the coefficients, and then it's y equals that constant. And if the degree is larger in the denominator, then you get y equals 0 as the horizontal asymptote. But here we get this oblique or slant asymptote. There's two ways to approach it. Long division is the way that always works, and maybe synthetic division. And that's only if it works. And there's a certain time when synthetic division works and sometimes when it doesn't. I can explain. But first, the long division. So we would take the x plus 1 and long divide that into x squared plus 2x plus 5. And x times x is x squared. And that is essentially x squared divided by x. And then we distribute, we multiply, and that gives us x squared plus x. We then subtract. X squared minus x squared is 0. 2x minus x is x. Then we bring down this plus 5. And we repeat. X divided by x is 1, and that's plus 1. We distribute x plus 1, and we subtract, and we get 4. And this part is the remainder. We let y equal the quotient, and that is the oblique or slant asymptote. Just the quotient, not the remainder. Now, if your denominator happens to be of the form x plus or minus a number, you could also use synthetic division. And a lot of students choose this because of how fast it is. But you don't have to do it this way because long division always works. Put the coefficients of the numerator in play. Set the denominator equal to 0 to find the appropriate 0, -1, that we'll use. Always bring this number down to start off, and then multiply and add, and multiply and add. And this again is the remainder. And this is a 1x, and this is a plus 1, and then y equals. That would be the other approach to this problem. It's always y equals because an asymptote is an equation. It can't just be x plus 1. That's not an equation. Y equals. And then don't use the remainder. All right, hope this helps.